So in the last video, we were talking about how can we handle arbitrary number of input arguments. For example, let's say we want to write an add function that should be able to add any number of, let's say, integer or floating point numbers that are passed in. Remember last time we discussed in an earlier video that when you are defining a function, the total number of variables that you are defining, you have to pass exactly those many input arguments, otherwise you are getting an error. But this may be required sometime that we want to add a universal kind of add function that has capacity to receive any number of arguments, but no matter how many arguments it receives, it just add them all and return the result. Such a function, if available, will be very helpful, because sometimes we might be calling that function by just 2 arguments. Sometimes we might be calling that function with, let's say, 3 arguments, and sometimes more arguments or less arguments, and so on. How can we have this kind of feature available, but the implementation is just one-time implementation? Well, Python have a very easy way of handling this arbitrary or variable number of inputs. And the way you do that is when you are defining a function, you just write a star and then just print, let's say, one variable name, let's say args. And then after that, this args will act like a list. And I mean, it will be having a lot of properties, args. This args has a property, this acts like a list. So all the arguments that you will send in will be received like you're receiving those in one list. And all the elements, which are the arguments in the list, they're accessed by different indices. We will see lists in detail later on, but right now just think it is a collection, all the collection, it is received by indices. For example, the args, the very first element is indexed by 0. It is at the 0th location. At the 0th location, there is a 3. At the first location, for example, the location index number 1, which is actually the second look, the 4 will be copied at this, and so on. Now, no matter how many arguments you pass, a list, it will be of that size. And there is a function length, len, that is handy to just check how many arguments are there. Now, if you pass 2 arguments, the length of the args will be 2. If you have passed 3 arguments, the length of the args will be 3, and so on. No matter how many arguments you pass, this args, it will receive all them in one by one, and all the elements in that args will be indexed by 0, 1, 2, starting from 0 until the length of the args. So see, for example, here the sum equals 0. Let's say we want to add all these for I in range, and inside range we just give the length of args. For this example, 1, 2, 3, 4, 5. The length of arg is 5. So I will start from 0 till 4, because 5 is not included. So the very first time I will be 0, and args in subscript 0 is actually the value of the first variable, which is 3. So 3 is added to 0. Then next time I will be 1, and at the position 1, 4 is located. So 3 plus equals 4, which means 3 equals 3 plus 4. Sum equals whatever the previous value of the sum plus 4. Then next time the value of I will be 4. You know how this loop works. We discussed the loops in detail. And as you move on, you actually explore all these numbers, and this variable sum actually contains the sum of all the variables. Now you can return this sum, and this particular function acts like a universal kind of function that receives arbitrary number of arguments. How cool is that? Let's see in Jupyter Notebook to get more convinced how it works. So let's say we have define, let's say we have any function, my add, let's say that's function, my add powerful, let's say, yeah, universal or universal, my add universal, and it receives star, whatever the variable name is. You can write the name args, or you can write any other variable name. This is just a name of a variable. Okay, then let's say we have s equals 0, which is sum. Then we just apply a loop. I guess you know the loops. We have lengthy discussion on loops. In range, length, that's a built-in function, length, args. Okay, then what should we do? S plus equals args I, which means access all the elements one by one, and this is again the same as s is equal to s plus args I. Either way you write this way or that way, both ways are fine. Then when the loop finishes, s contains the sum, just return it and you are done. Wow. Now let's call this add function my add universal, and let's call this function as 2, 4 and 5 for these, and let's just print the result. Okay, the result is 11. Wow, because 2 plus 4 plus 5 is 11. Now let's call this function for, let's say, for let's say 5 arguments. It works. It adds all these 5 numbers. Wow, that is great. I mean, now we can add any. We have one function. We need not to write a function for 2 arguments, and then another function for 3 arguments, then another function for 4 arguments, and so on. Depending upon the number of arguments, we need not to write separate functions. We have just one function working in all scenarios. Wow. So yeah, that's doable. I've done in front of you, no problem. Yeah, Python allows this. In the next video, we are going to see how can we actually handle the same kind of scenario, but we want to handle the sequence of the input variables in a very controlled way. Remember in some of the previous, in this order of input arguments, remember that we received 3 arguments and we passed the 3 arguments in a very controlled way. And then whatever these are, we don't care. Whatever the order here, we don't care. What if we want to fix the input, or we want to become more careful for input argument orderings, but then we also want the arbitrary number of arguments? How can we do that? Yeah, wait for the next video and I will show you how can you do that.